Hello everyone, I'm going to be making Damascus from gears. So this is gear Damascus. Cutting off a little piece of square tubing, 3" by 3". And I'm going to paint the inside of this with white spray paint. Principal component of that is titanium dioxide. Prevents it from fusing to the metal powder and the gears on the inside of this. So I paint it thoroughly and prevents the can from sticking. Makes extraction of the can very easy. So I weld the bottom of this shut. I tack it, run some beads across that, and get that sealed up. You can't have any air get in there. You're looking for an oxygen-free environment inside the can. Now, sometimes I will drill a hole in this canister style Damascus because it is prone to bulging and bursting. You can have the can burst. So, let's weld it up. Now, once it's all welded up, I usually touch up the paint a little bit on the inside of it, but I'm not sure I did that on this one. So here's the gears. These gears came out of a hydraulic motor for a concrete saw. There's a hydraulic saw, and these came out of a hydraulic saw. So I cut the shafts off of these. These are all on shafts. I cut the shafts off and kind of ground them, the ends a little, ground them and smooth them off. And so I'm going to stack them like that inside the can vertically and fill the rest with metal powder, very fine metal powder. Here's one of the gears without the with the shaft still on it. But this is a very hard type of steel. I think it's 8660, 8660 I think is the type of steel. I'm not 100% sure on that, but it's a very, very hard, very tough metal. And so, and it is heat treatable. These can reach a very high hardness. So I'll be pairing it with nickel powder. Well, I think it's 1080 with 4% nickel powder. So, and so this is the powder I'm using from Jantz. It's a very fine powder, as you can see there on the label. So you have to be a little careful. There's an inhalation hazard. This metal is so fine, and once it gets in your lungs, it is next to impossible to get it out. It can lead to some problems. You're actually supposed to wear a respirator when you're using this material, but I have to be honest, I don't wear a respirator when I'm using it. You can see here, I got the GoPro close. You can see just dumping it. You can see how fine of a powder that is. So you do have to be careful using this. So yeah, so that's what I'm using. So I have the can here, and I'm running a torch on this can real quick just to get just to heat it up and get all that solvents out of it. Now once the can is heated and all the solvents are out of it, it's fully cured, I start stacking the gears in there, and I kind of orient them. I want the gears spaced out a little bit. I want to see a little bit of shiny material in between the gears, so I don't have them interlocked perfectly. I have that little bit of a gap, and I was debating about going with a bigger tube to give me more room to the sides, but I eventually went with 3" square tubing because I had some of it on hand. But a little bit bigger tubing would have been a little better because my inside diameter, this square tubing wall thickness was 1/8 of an inch. So it was actually like 2 3/4 on the inside diameter of that tube. But I'm stacking the gears in. You can see I've cleaned them thoroughly with a grinder. And I'm stacking them in, and I'm putting the metal powder in, and just stacking them and putting the metal powder, tapping it, stacking it, putting the metal powder. And so that's what I'm doing. You can see the final stack is getting close. And I'm just fitting these together, getting them interlocked properly, getting a little bit of a gap, and filling it in with metal powder. This is kind of what it looks now. I debated whether or not to forge this with the gears oriented laterally, but I knew I was going to cut and restack this billet. So I stacked all these kind of vertically in the can, and then I'm going to forge it out, draw it out, keeping it square but elongate it, and then I'm going to cut those and turn them so the gear patterns on the sides of the billet, and then reforge that after. So here's some shots. I'm just filling it in, and so I'm going to drop a little a square piece of steel on the end of this, the end cap, and weld that. So just throwing some welds in this, and then once it's welded, I put a little handle on this, rebar handle, and then I'll be ready to go into my forge. And it turns out I didn't drill a hole in this. Some of these welds are just, I'm not trying to do, my best welds ever. So there is a little bit of porosity in some of these welds, especially where they overlap, and so that they naturally have some venting capability. So I'm shooting for 2350 is my temperature, and I was close. I had that temperature, it was really close. So, and see here, this is the first heat, and I'm drawing it out. I got my squaring dies, so everything's going great. I got my proper heat. I made sure there's oxygen-free environments inside that can. It's sealed properly, and I'm just forging it out here. These squaring dies are pretty effective at kind of getting pressure from all four sides, because a lot of that powder is loose initially in the first heat, but after like the first 3 or 4 presses, I start to feel it firm up. You can actually kind of feel it in the press when you're operating it. So I think I did 3 total heats on this. Yeah, 3 total heats, and I made sure I was at my proper forging temp. Now I did have the can. My can came off on one of this. Now I'm on my drawing dies. I'm drawing this out. So it's been properly consolidated. So now I'm just elongating it. Now sometimes I'll cut the can off before I do this, but I found that if I elongate it, the can comes off much easier. As I reduce it in volume, the can seems to want to stay at a bigger size. So I'll actually draw it out with the can on. You'll see the can here, the can splitting off, and to be honest, that's desirable. These cans come off very easy. You can see here, the can just pops right off. Now, you can see the titanium dioxide paint there as a barrier, works very effective, and keeps that material from sticking to the can. Yep, and this can just fell off. The billet just dropped right out. And so, yep. And the spray paint's the cheapest. A lot of people use whiteout. It's a little messier to work with, and you just need a light coat of some cheap white spray paint, and you're good to go. Now here's I've already separated these out. Now I cut this into 3 pieces. I'm going to turn them sideways. You can see I ground a small relief on the edges, but this is one that has been ground already. You can see the surface of this. It's ground, and this is the kind of surface finish you got to get. It has to be ground perfectly smooth, a very high degree of grind for it to fuse properly. Now you can see the gear pattern in there a little bit. That's going to be on the sides of the billet now, once I restack this. So in this next shot here, I'm milling. Some of these were irregular, the surface was, so I threw it in my milling machine, and you can see those chips are coming off. Those chips are blue and purple. This this gear material is very hard. This is a carbide end mill, and it was kind of struggling to cut this. I had to get my feeds and speeds just right, but I had to square up some of these billets, so they have to fit together perfectly. You can't have any gaps in it. They have to be very perfect. Now on the welds, you'll see on this next shot, I did not MIG weld this or stick weld it, because when you press it, after you initially press it, it presses that weld in and contaminates that billet. So what I'm going to do is I'm going to use a fusion weld. I'm going to TIG weld it, and that's going to leave that. It's going to not have any inclusions in that. So I just run argon here at around 15 CFH. I'm running about 150 amps. No filler rod. I'm just fusing these billets together. That's it. It's just a fusion. That's going to seal that. I TIG fused that. It's called autogenous welding, where you don't use filler rod. I fused all the way around the circumference of those mating joints of these restacked blocks, so that no air gets in, and then there's no contamination. I'm not leaving a rod or filler rod or anything like that. It has to be ground away. I've made that mistake before. It's on a previous video, you can see, but it's a real pain. It's not the end of the world. You just have to grind that out. But you can see here, I TIG fusion weld all the way around this, and then it's all sealed off and ready to go back and get reforged. So here you're going to see I'm going to hit this vertically under the press. I made sure I'm at a good temp, and here's the first squeeze, and that's to fuse that together. Now those unions where those blocks were restacked were ground to almost a mirror finish, and they were cleaned with acetone, and they were clamped sufficiently, and then there can't be any air in there. If you let air get in there, or there's it's not totally sealed off, or the mating surfaces aren't perfect, you'll have a cold shut, and you'll see a subsequent. I'll turn this. Now this really tells you if you have fusion. Watch, I'll turn and hit this sideways, and if it's not properly fused, those chunks will fall apart. And you can see here, I'm starting to stretch it back out to maintain the proportions. I want these gears to be a certain type of visual proportion. So you can see after I got the vertical thing, the billet crushed and fused, I'm drawing it back out again. I'm going to do this several times actually. I'll draw it back out to its original net shape. I'll throw it back in my furnace, and then I'll vertically hit it again. So I want to make sure this is fused. This is very critical. I don't want to have to stop and redo this. Sometimes you can get to a point where it's sometimes better to start over, believe it or not. But so I'm drawing this back out after I initially pressed it vertically to press those cubes together. So I'm drawing this back out again. And then the temps are real critical on this. You got to get your temps. I'm shooting for 2300 degrees. And so, and I have my pyrometer. I have a digital pyrometer with a Type A thermocouple, and it's giving me the furnace temperature. And so here, I'm going to get another heat on this. I'm going to throw it in and stack it vertically again, or press it vertically, and then I'm going to turn and draw it out again. I want to make sure this is fused. Now I did have a little bit of it was binding a little bit, or not fusing, or not reducing in height perfectly, so I'll turn it, and now I'm kind of straightening this out. My net shape is pretty good, but you'll see here I'm turning this, flipping it, and I'm kind of straightening this out. I got in some of the, and then one of those vertical presses, it was kinking a little bit, so I'm re-squaring it here. So I'm getting this. I do this a couple times. I'm kind of judging by eye what that size is. So, and chances are I'm going to fuse that edge. I'm going to get a piece of monosteel and forge weld it for the knife edge of this that this billet's going to be. So here it is, guys. It's coming up. It's going to be incredible. This is just pulling it out right now. These are the first shots of this, taking it out. Look at this. It's incredible. I mean, this pattern came out great. Now this is just a light grind. I didn't grind this very well, so you can see there was some nickel over a couple of the gears, and they're not fully, the contrast is not really sharp. I didn't do a good grind. This was just a light grind, just for etching, just to look at what I have. So it's not perfect. These should be crisper if I would have ground it to a higher degree, a higher finish, and etched it properly. This is just a quick etch in a pretty high concentration just to show you the pattern of this. So part 2 is coming out. I'm going to make a knife out of this. I want you guys to stay tuned. I'm working on this knife right now. It's going to be incredible. But look at this pattern, guys. I love it. Damascus from gears. It just came out. It's just incredible. I really appreciate you guys watching. Thank you very much. And tune in for part 2. Thank you.